These are vocab cards 5 through 8, so you'll need another 4 vocabulary cards, highlighters, markers. And remember, you can pause this video anytime you want. And one thing that I wanted to bring out about the last ones is as you're doing these, since I have them numbered on your cards, let's number these in the upper right hand corner. So integers is 1, rational numbers 2, absolute values 3, and additive inverse and multiplicative inverse are 4. So for adding and subtracting integers, that one's going to be 5. Okay, now I'm putting both of these together because they really have a lot of the same properties. So adding and subtracting integers, we have this concept. -12 plus 9. And we did lots of different things to represent this. We talked about having 12 negatives, 9 positives, and then we talked about how they're going to go to war. And anytime there's a positive and a negative, those zero out. And you really count up how many negatives will be left after these 9 positives cancel them out. So as you continue seeing that, the negative team is more powerful because -12 has a larger absolute value, and it's going to win by 3 people, so the answer is -3. Okay, we can also see that written in opposite order. So sometimes it might look like this. And here's what I was talking about with that absolute value symbol. If you see something like 7 plus -4, a lot of times they'll put -4 in parentheses so that they don't have a plus and a minus symbol right next to each other. But many kids mistake these parentheses here and they think that means absolute value. Remember, absolute value is only when the lines are straight up and down. So this means 7 positives are fighting 4 negatives. So the positive team's more powerful. And when the 4 negatives cancel out the 4 positives, we're going to be left with +3. Okay? The next thing that we have to recall is what happens, or I guess, let's just do one more example before I go on, is what happens if you're adding together 2 things that are the same sign. So we've got 3 negatives plus 2 more negatives. Notice that both these people are on the same team. They're all on the negative team, so they're not going to fight each other off. We're just totaling that up to get a total of -5. Okay? So if you use this concept of winning the war whenever you're adding positives and negatives, it really will work for you. The problem comes in is when we introduce subtraction. So when we introduce something like this, 5 minus 9. And what you need to remember is that subtracting means the same as adding the opposite. So 5 minus 9 is the same as 5 plus -9. And then you just use all these same rules. The negative team is more powerful. There's 9 negative teams against 5 positives. Once they battle each other out, you're going to be left with 4 negatives. Okay, so we need to get into the habit of being able to change a long expression all into addition. So if you have 5 minus 6, you want to think of this as 5 plus a -6. So we add the opposite. Minus a -8, we add the opposite of -8, that's going to become +8. And -7 becomes adding a -7. So being able to translate any subtraction sign into adding the opposite will help you out greatly. So looking at this problem, let's add the positive team together first. We have 5 positives and 8 positives, so that ends up being 13 positives. Then if we add the negatives, we have negative 6 plus negative 7 means we're left with 13 negatives. And when these guys go to war, notice they are additive inverses, so they are going to all cancel out and we get 0. Okay, so let's just do one more problem. If you see something like this, 5 minus a negative 6, you always want to remember this phrase. We want to add the opposite. So instead of subtracting negative 6, we are going to add positive 6. And that becomes 11. Okay, your next card is card number 6, multiplying and dividing integers. When you multiply and divide integers, or any numbers, you need to keep in mind the rules. So, straight up, a positive times a positive is always going to be a positive. But what happens when we incorporate one negative number, like negative 4 times positive 3? Well, if you think about multiplication, this means we need 3 groups of negative 4. So we've got there's one group of negative 4. There's 2 groups of negative 4. There's 3 groups of negative 4. And when you add those all up, you see you have negative 12. So one negative times a positive is always going to be a negative. Okay? And if you have 2 negatives, negative times a negative becomes a positive. So the rule is, in a problem, if there is an odd number of negatives that are being multiplied, the answer is negative. So here, 1 negative, 1 is an odd number, the answer is negative. If there's an even number of negatives, it becomes positive. Okay, so let's take a look at something like this. Let's write it up here. Negative 2 times positive 3 times negative 4. Well, you count up your negatives. Since there are 2 negatives, that's even. That means it's going to turn it all to positive. So 2 times 3 is 6. 6 times 4 is 24. The answer is 24. The same rules apply for dividing. If you take a whole a number and you divide it by a negative, a positive divided by a negative, there's 1 negative in the problem, the answer is negative. If there are 2 negatives in the problem, when you divide, the answer is positive. Okay, now let's go down here and just review this. What would you do if you had negative 1/2 divided by 3/7? Well, you have a negative divided by a positive, so your answer is going to be negative. But we just want to review dividing fractions, and this potentially could have been a whole nother card. But we use something called, we multiply by the reciprocal. So negative 1/2 stays the same, but we change the division and multiplication, and we take the reciprocal of 3/7, which is 7/3. And now when you multiply across, you get negative 7 over 6. And you can leave the answer like this, or you can turn it into a mixed number, negative 1 1/6. Okay, so let's turn the card over. And I think we're going to do a couple problems like this. So can you guys do this? And remember, we're going to multiply by the reciprocal. Let's try these two. So pause the video and do both of these problems. And we will talk about this problem in class once you have those done. Okay, your next card, card number 7, is called distributive property. Distributive property looks something like this. When we say -3 times the quantity of 2x minus 4. So notice we have two operations. We're saying -3 times, but these parentheses mean we're not just multiplying -3 times 2x, we're multiplying it by this whole group. So we want to draw two arrows to show that we need to distribute, or we need to pass out -3 to both of these things. So -3 times 2x is -6x. And here's that little subtraction again. So whenever I see a subtraction sign, I always want to do add the opposite, because that's going to help me realize that this is a -4. So what's -3 times -4? +12. Now I look at this answer. Is there anything I can add together? And the answer is no, because these are not like terms. Okay, so let's try a different one. So let's do 1/3 times the quantity of 4m minus 21. Well, this means we have to do 1/3 times 4m. Well, 1/3 times 4m, I'm going to think about this as 4/1. So when I multiply this 1/3 times 4/1, I do numerator times numerator, denominator times denominator, I get 4/3 m. Now I'm going to multiply here. 1/3 times this number. Well, is this 21 or is this -21? Well, because of the subtraction sign, it's really -21. So I'm going to think about this as a fraction, -21/1. So I multiply numerator times numerator. I get -21 on top. Denominator times denominator. 3 times 1 is 3. And notice that -21 divided by 3 is really -7. And here's my answer, 4/3 m plus -7. Okay, the last one I'd like you to try is this. Okay, so I added one more step here. This looks like -4 times this quantity, but then we have this extra minus 2x. Notice that this is not in parentheses, so it has nothing to do with the distribution. So we're going to distribute just like we would before. So -4 times 3x is -12x. And -4 times +2 is -8. And now I bring down this minus 2x. And notice, unlike the other problems, now I have some like terms to add together. I've got -12x, and thinking about adding the opposite, I have -2x. So the answer comes out to be -14x, and I still have this -8. So I think you saw a problem like that in your review packet. And the last note card is number 8. It's called factor an expression. To factor an expression, it's the opposite of the distributive property. And I just want to remind you, I'm kind of going quick, but please feel free to pause the video as needed. So we're going to start out with something like this. 5x plus 15. To factor this expression, we want to look at each of these terms, 5x and 15, and we want to see, is there a GCF, a greatest common factor? Is there a factor of 5x and 15 that is in common, and if so, what's the largest number possible? Well, notice that 5 is the greatest common factor. So 5 is going to become the number outside the parentheses that we distribute. So then you want to think to yourself, if you take out or factor out a 5 out of 5x, what you're really thinking about is if you divide 5x by 5, what's going to be left? X. And if you divide 15 by 5, what's left? A 3. And you can check if your answer is correct, because if you do the distributive property now, you should get right back to where we started. Okay, so let's try this one. So you need to figure out what is the greatest common factor that 12 and 18 have. Well, they both have a factor of 2, but that's pretty small. So let's see if there's something bigger. 6 is a factor of both. Let's see what else. 4 is not. 3 is not bigger than 6. So I think 6 is the biggest factor these both have in common. So we're going to pull that 6 out. And when you factor a 6 out of 12x, when you divide 12x by 6, you're left with 2x. And when you divide 18m by 6, you're left with 3m. And so that is completely factored. Okay. Now factoring will work for something that has many terms. So if we had something like this, three terms, we could also factor. So you look at these numbers, 15, 20, and -5, and try to find the greatest factor they have in common. We'll notice they all are multiples of 5. So 5 is a factor. So now you go through and divide each of these by 5. 15x divided by 5 is 3x. 20y divided by 5 is 4y. And -5m divided by 5 is -m. Remember, this is really a negative. So if you check this with the distributive property, 5 times 3x is 15x. 5 times 4y is 20y. And 5 times -m is -5m. Okay, you can please add these to your rings, and you can spend the remainder of your time working on your M-Step packet.